So GC has been equilibrating for a while, and you can see that we're stable at 275 injector and detector temperature and 190 on the column. So what I'm going to do now is I'm going to free the CBM, the communications bus module. I'm going to blow this up, and then I'm going to use the 0 knob to adjust that to the 0 position. And then I'll lock it there. And I can increase my sensitivity as I get close. It doesn't have to be exactly on 0, but it's nice to get it reasonably close to the 0. That's good enough. I'm now going to 0 that CBM, and it'll set it to exactly 0, and then I can move back out to a less sensitive. You'll notice that it fluctuated quite a bit over the time while it was equilibrating. And it even looks like something came off that was perhaps clogging the column from a previous run. So now I have a nice stable baseline at 0. My GC is ready to go. It's now time to set up the rest of the reaction. So the reaction is going to be between 1,3-cyclohexadiene, which I took out of the refrigerator, and N-phenylmaleimide. And the solvent is going to be ethyl acetate. I've already gotten out a hot plate and a stirrer. We're going to be running this reaction in a 50 milliliter round bottom flask, and I'm going to get one from my hood. I'm using that hood because it's close to the GC, which means I won't have to move very far. But I'm a little bit more confident of the cleanliness of the flasks from my own hood. So a 50 milliliter 1922 flask, that one looks nice. And I got a holder. And we want a air-cooled condenser. We're just going to sit that condenser on top since we're not going particularly close to the boiling point. That one looks like it's less wet inside. We don't need to run cooling water this time. And a football-shaped stir bar. And a nice clean graduated cylinder as well. So this is going to sit in a sand bath with the air-cooled condenser on top. So I need a sand bath. And it's very important for this reaction, since we're trying to get a rate constant at a given temperature, it's very important for this reaction that we have a reliable, stable temperature. I'm going to need my timer. So I'm going to fill my sand bath about half full this time. I have a little bit more sand, but I need to make sure I get my flask really sunk down deep so that the temperature I'm measuring with my thermometer is reliable. So the timer can go up here. I need that at some point. Some junk in my sand. It's not going to be very hot. I'm going to want a setting on my dial here to get to a temperature of 40. I'm going to try to run this at 40. I'm going to want a setting probably a little bit over 50, like maybe at the 60-ish range. It's a little hard to tell. So we'll have to monitor that over time. And I can use a 150-degree thermometer because I don't need to go any higher, and that will allow me to get a slightly more accurate temperature reading. So the first thing to do is going to be to measure 780 milligrams, 0.78 grams of N-phenylmaleimide into this flask. Naturally, this hood doesn't have anything that I need. So we'll get one of those spatulas from my own hood. So I'm going to tear the flask. We have everything in it. And then I'm going to measure my solid directly into the flask. But I don't want to spill on the balance, so I'll take that out for now. So we'll see about how much that is, and that'll give me an idea how much more I need to add. So that's about 0.1. We're at about 0.52 now. It's important to get accurate masses this time as well, because we want to make sure we have a 1-to-1 ratio of our two reagents. If we don't have a 1-to-1 ratio of our two reagents, we can't use that simplification for the kinetic analysis that allows us to integrate A squared dA rather than A times B times dA, which would require partial fractions. And we really don't want to do that. So we're a little over. We're at 0.8. We just need to take a little bit more out. Kind of flaky solid. And that is pretty accurate. Seems to be stabilizing at 0.779 grams. I'm not going to mess with that. 0.779 grams is close enough to 0.878 rather. I'm actually done with that, so I can put it back in the cabinet it belongs in and take my flask to my hood. This is not really very dirty. I'll just give it a wipe. The other reagents are all liquids. So I now want to dissolve that in 12 milliliters of ethyl acetate. I'm going to dispense that with a pipette. And what I usually do is stick my pipettes in test tubes or small flasks. I use test tubes today. The reason for using hood 6 instead of hood 10 this time is just so that I can be really close to the GC I'm using, so I don't have to move very far. I can get my injections in there as close as possible to the time that we want. So this is 10 mil graduated cylinder, so I'm going to do it in two 6 milliliter batches. I'm going to use 12 milliliters to dissolve my N-phenylmaleimide, and then I'm going to use the remaining 3 of our total 15 milliliters of solvent to dissolve the cyclohexadiene in a different vessel. That's 6. We have 12 milliliters in there now. I'm going to go ahead and measure out the 3 milliliters that I need later while I have the bottle open. pipette in the back. It's the one I'm using for the ethyl acetate. And this one would be the one I use for the cyclic hexadiene. So that 3 milliliters is set aside. What I want to do now is clamp this guy take my thermometer away for a minute. I want to make sure I don't break it. And then I'm going to try to sink that as deep in the sand bath as possible. I really want to try to get that all the way down to the bottom so that the sand bath is heating it really efficiently. And put on my air-cooled condenser. I'm going to set this at a stirring of 450. And I'm going to stick my thermometer back in there. And I'm going to angle it to get the thermometer as close as I can to the bottom of the flask, so that I'm pretty sure that the thermometer bulb is reading the same temperature that's inside the vessel. And again, we can use the spatula to scoop the sand around. And we're now trying to get that to equilibrate to a 40-degree temperature that's going to be nice and stable over time. You'll notice that the solid is gradually dissolving. It's not completely dissolved, so it'll need to sit there for a while to get completely dissolved. And we're at about 35 degrees. That may be rising a little bit. You can see that it's still flickering, so it's still heating. So let's just leave that and let that kind of sit and equilibrate.